Have you ever wondered about the current state of our energy grids and the potential for optimization? Let's dive into it. Our energy grids, as they stand, are complex networks designed to deliver power from producers to consumers. They're an intricate web of generators, substations, transformers, and more. But they're not without their limitations. Inefficiencies and reliability issues are rife. Blackouts, energy loss during transmission, and the challenges of integrating renewable energy sources are just a few of the hurdles we face. For energy companies, these issues aren't just inconvenient, they're costly. But what if I told you there's room for improvement? That optimizing these energy grids is not only possible, but essential for energy efficiency and reliability. The question then arises, how can we optimize these energy grids? The answer lies in the McGinty equation. The McGinty equation might sound complex, but let's break it down into simple terms. Imagine a symphony orchestra, each instrument playing its part, contributing to the overall harmony. The McGinty equation, in its simplest form, is like this orchestra. It's an equation that brings together different elements to create an optimized energy grid. Now let's look at the different components of this equation. The first part, PSQFTXT, is the solution of the free quantum field theory. Think of it as the conductor of our orchestra, leading and coordinating all the other elements. Next, we have the Fractal X to D MEQs component. This is a bit like the string section of our orchestra. It represents a fractal structure, a pattern that repeats itself at every scale. Just like how the same musical phrase can be played at different octaves, this fractal structure repeats itself across different scales and dimensions in our energy grid. But the original McGinty equation had limitations. It didn't account for one very important player, gravity. This is where the modifications come in. The modified McGinty equation adds another component, Peace gravity XTG. This represents the effects of gravity on the quantum field, like the brass section adding depth and richness to our symphony. Gravity, characterized by the parameter g, is like the subtle but powerful force that can change the way the entire orchestra plays together. By adding this component, the equation now accounts for the perturbative effects of gravity on the quantum field, allowing a more holistic understanding of the energy grid. Finally, the fractal potential term VYT has a self-similar fractal structure, much like the Peace fractal XTDMQS component, but it provides a correction, fine-tuning the equation. It's like the tuning of the instruments before the concert begins, ensuring everything is pitch perfect. So, in essence, the McGinty equation, with its modifications, offers a blueprint for understanding and optimizing energy grids. It's a symphony of components, all playing together to create a more efficient, reliable energy grid. Now that we understand the McGinty equation, we can dive into the world of quantum-assisted energy grid optimization. The underlying principles of the McGinty equation serve as the foundation for this cutting-edge method of energy management. Essentially, what we're looking at is the application of quantum field theory and fractal mechanics to the optimization of energy grids. This might sound a bit complex, but let's break it down. The McGinty equation, in its simplicity, is all about the interaction of quantum fields and gravity. It's the bridge between the quantum world, with its unpredictable and often counterintuitive behaviors, and the more familiar world of classical physics. Now, when we introduce the concept of fractal structures, which are self-replicating, infinitely complex patterns, things get really interesting. That's where quantum-assisted energy grid optimization comes into play. By harnessing the power of these quantum and fractal principles, we can begin to see patterns and predict outcomes in energy distribution that were previously beyond our reach. We can simulate, analyze, and optimize energy grids in ways that were unimaginable before. And the benefits, they're substantial. First off, we're talking about increased energy efficiency. By being able to predict and manage the flow of energy with unprecedented precision, we can reduce waste and make the most of our resources. This is not only good for the bottom line of energy companies, but also for the environment. Secondly, we're looking at improved reliability. With the ability to foresee potential issues and address them proactively, we can ensure a more stable, uninterrupted supply of energy. This means fewer blackouts and more consistent power for homes, businesses, and industries. Quantum-assisted energy grid optimization is more than just a theoretical concept. It's a practical tool that's set to revolutionize the way we manage and distribute energy. Quantum-assisted energy grid optimization, therefore, holds great potential for transforming our energy systems. So, where does all this leave us with the future of energy grids? The dawn of a new era in energy management is on the horizon, one where quantum-assisted optimization takes center stage. The potential for this technology is nothing short of revolutionary. Imagine a world where energy grids are so efficient, so finely tuned, that blackouts become a thing of the past, where every flicker of energy is accounted for, used to its fullest potential without any wastage. But how does this happen? The answer lies in the McGinty equation. This equation, which involves quantum field theory and fractal structures, allows us to understand and predict the behavior of complex systems, like energy grids. When combined with the power of quantum computing, the McGinty equation can help optimize these systems in ways previously unimaginable. Energy companies stand to gain immensely from this. With quantum-assisted optimization, they can manage their grids with unprecedented precision. This means fewer operational hiccups, less maintenance, and ultimately lower costs. It's not just about the bottom line, though. More efficient grids also mean more reliable service for customers. No more unexpected power outages, no more fluctuating voltages, just smooth, uninterrupted power supply. The benefits don't stop there. An optimized energy grid is also a greener one. By eliminating energy wastage, we significantly reduce our carbon footprint. This can have profound implications for the environment, helping us combat climate change and create a more sustainable future. Indeed, we are on the brink of a quantum leap in energy management. Quantum-assisted optimization, powered by the McGinty equation, promises a future where energy grids are not just more efficient, but also more reliable and environmentally friendly. A future where energy companies can deliver better service at lower costs, while also doing their part for the planet. With the McGinty equation and quantum-assisted optimization, the future of energy grids looks bright indeed.